Ever plugged in like a USB drive to your Linux machine and kind of wondered where it went? It's not like in Windows where it pops up as like E drive or whatever.
Right.
So today we're going deep, deep into the world of Linux storage. We're talking hard drives, we're talking flash drives, the whole shebang.
Yeah.
We're going to decode how this operating system, how Linux sees your storage devices. We've got a ton of sources here, articles, forum discussions, even a few pages from a Linux security handbook that we're going to unpack.
Yeah, looking forward to it.
You ready to unlock the secrets of like these cryptic file names? Like, what is devsamd1?
Oh, absolutely. What I think is so fascinating about Linux is that those names, they aren't just gibberish.
Okay.
They're like little breadcrumbs leading you to this surprisingly elegant way of organizing things.
Yeah. Okay, I'll bite. Our sources keep mentioning this mysterious, like, dev directory. What's the story there?
So picture the dev directory, right? Like Grand Central Station.
Okay.
But instead of travelers, it's full of devices.
Yeah.
Hard drives, keyboards, your webcam, you name it. If it's connected to your Linux system, it's got a dedicated file just hanging out in dev, waiting to be accessed.
So it's like each device gets its own little file avatar to represent it to the Linux operating system.
Exactly. Think of these device files as the official communication channels between Linux and your hardware.
Our deep dive today is focused on storage devices, specifically.
Right.
And the sources, they get like really detailed about how these device files are named. And it seems like understanding this whole naming system, it's super crucial, especially if someone is interested in ethical hacking or even system administration.
Absolutely. Let's take that head scratcher you mentioned earlier, the Devs Logia 1. It's not as complicated as it looks once you know the code.
Yeah, I have to admit, whenever I see those names, I'm always like, man, I need to brush up on my Klingon.
No universal translator is needed, I promise. That SATA, that's just Linux's way of saying first SATA hard drive.
Yeah.
SD stands for SATA. The A means it's the first one in line. A second SATA drive would be SDB, and so on.
Okay, that's pretty straightforward. But what about the one at the end? Is that some kind of like Linux priority ranking?
Good guess, but no. That one is telling us we're looking at a specific partition on that drive. So Linux lets you divide a hard drive into these separate sections called partitions. They're like self-contained mini drives within the main drive.
So Dev's Data 1 is like the street address for the first like apartment in the CETA building.
You got it. And if you had multiple partitions on that drive, you'd see Devs Day 2, Devs Day 3, and so on. It's all about that structured organization.
That makes a lot more sense. It's like a logical map of all the storage, like nooks and crannies on my system.
Yeah.
But how does this compare to how Windows or Mac OS handle things? I'm used to just seeing drive letters like C or D.
Right, that's the key difference. Windows and Mac OS, they rely on those drive letters, which, let's be honest, can get pretty messy if you're juggling like external drives or a bunch of USB sticks.
So how does Linux avoid becoming like a chaotic jumble of storage devices? Our sources mention these things called like logical labels and something about mounting.
Yeah.
Sounds very official.
It might sound official, but it's actually where Linux shows off its flexibility. So instead of those fixed drive letters, it uses these logical labels, which are basically user-friendly nicknames. You can assign them to different storage devices or partitions.
Wait, so I can give these devices my own nicknames?
Yeah.
Like I could name my external hard drive Backup Haven or something like that?
Essentially, yes. But these nicknames, they're more than just for fun. They actually tell Linux where to integrate these devices into its file system hierarchy, and that process is called mounting.
Mounting, like I'm prepping, like a prized beetle specimen.
More like placing a prized book on your bookshelf. Okay, picture your Linux file system as a giant library.
Okay.
Mounting is like taking a new book, your storage device, and placing it on a specific shelf. That's your directory in that library.
So instead of everything being scattered across different drive letters, it's all neatly organized within the Linux file system. I like the sound of that.
Exactly. And here's the kicker. You have a lot more control with this approach. You can mount a device to any empty directory you want, giving you the freedom to organize things exactly how you like it.
Our source uses the example of mounting a flash drive at Lucia Media. So instead of it being E or something generic, it becomes part of that media neighborhood within the Linux file system.
You got it. It's a much more unified approach, wouldn't you say?
Definitely a breath of fresh air compared to the alphabet soup of drive letters. But this all sounds very hands-on. Are there specific commands I need to learn if I want to start mounting and unmounting devices like a Linux Pro?
You bet. There are a few essential commands you'll want in your Linux tool belt. And lucky for you, we'll break them down right after a quick break.
All right, we're back. Before the break, we were kind of mapping out, like, the landscape of Linux storage.
Right.
Now let's talk tools.
Yeah.
Our sources make it clear that knowing a few key Linux commands can really, like, up your game.
Yeah.
Especially for things like ethical hacking or system administration.
Oh, absolutely.
What's the first command we should add to our arsenal?
First up, lsblk.
Okay.
Now, if you're picturing some, like, complicated command line interface, think again.
Yeah.
This little gem gives you this clear, tree-like diagram of all your storage devices. Hard drives, USB drives, partitions, along with their sizes and where they're mounted. It's like having X-ray vision for your storage setup.
So I can just type in lsblk and bam, I see, like, everything laid out in front of me.
Pretty much.
Don't I need special permissions for that kind of system info?
That's the beauty of lsblk. It plays nice.
Oh.
It doesn't demand root access for basic usage. You can satisfy your inner control freak without having to put on the super user hat.
I like the sound of that. Easy access to information is always a good thing.
Right.
But let's say I've got, like, my trusty USB drive plugged in, and I want to actually use it.
Yeah.
How do I, like, bring it into the Linux world? We were talking about mounting before the break.
Right, that's where the mount command comes in. Think of it as rolling out the welcome mat for your USB drive, you know?
Okay.
Giving it a designated spot in your Linux file system.
And if I remember correctly, our source used the example of mounting a flash drive to the media directory. So I'm basically assigning a spot in the media neighborhood for my drive to, like, hang out.
You've got it. It's like setting up a dedicated workstation. Media is a common area where you connect external devices, making them easily accessible.
So if my flash drive is showing up as SDB1, because we're fluent in Linux device names now,
Right.
I would use the command mount dev/SDB1 media, and bam, it's ready to use.
You're a natural. But, you know, here's a little safety tip from the Linux pros. Just like you wouldn't rip a flash drive out of a Windows machine without safely ejecting it, Linux has its own etiquette for, like, saying goodbye to devices. That's where the mmount command comes in.
Right. Got to be polite to our devices. So before I unplug my flash drive, I would use mount dev/SDB1 to let Linux know it's time to, like, back up.
Exactly. Think of it as the proper Linux send-off, ensuring your data doesn't get scrambled in transit.
Okay.
Speaking of data, our source also mentions this mysterious file called etc.fstab.
Yeah.
What's the deal with that?
Yeah, it sounds like something only, like, hardcore Linux gurus mess with.
Right.
Should we be worried about it?
Not at all. Think of etc.fstab as, like, the autopilot for your storage devices. It's a simple text file that tells Linux which devices to mount automatically when your system boots up. It's what makes your main hard drive instantly accessible without you having to lift a finger.
So it's like the behind-the-scenes stage manager that makes sure everything is, like, set up and ready to go before the curtain rises.
That's a great analogy. Most of the time, you can let etc.fstab do its thing quietly in the background, but knowing it exists is handy if you ever want to customize how and where devices are mounted.
Good to know. We've got options if we want to get fancy.
Right.
But for now, let's get back to those essential commands.
Right.
We've covered listing devices and the fine art of mounting and unmounting. What other tricks does Linux have up its sleeve?
Well, now that you know how to access your storage devices, let's talk about keeping an eye on them. Think of it like checking the fuel gauge on your car. You want to make sure you're not about to run out of space.
Okay.
The df command is perfect for this. It gives you a quick snapshot of how much disk space you've used and how much is still free.
And our source specifically mentions using df to check the space on a flash drive mounted at Media USB 3.0. So I could use this to make sure I've still got room for those important ethical hacking tools, right?
Exactly. df is your go-to for a quick storage checkup. It's all about staying informed. But sometimes, even with the best of intentions, things can go a little haywire in the digital world.
Uh-oh.
File systems, like any well-used system, can develop errors.
Uh-oh, that doesn't sound good. Are we talking about, like, the blue screen of death here?
Oh, no.
What happens when those digital gremlins strike in Linux?
Don't panic. Linux has a built-in remedy for those moments. It's called FLESC.
Okay.
Short for File System Check. FES for us is your digital mechanic, ready to diagnose and repair those pesky file system errors.
FIS sounds like a lifesaver. But like any good mechanic, I'm guessing there's a specific procedure for enlisting its help.
You're right. The golden rule before running Shock, always, always unmount the drive you're about to work on. It's like making sure the car engine is off before you start poking around under the hood. So if we suspect a problem with that trusty USB drive, you'd use mount to detach it safely and then unleash the power of Shock.
And just like a seasoned mechanic, I'm betting Schruck comes with some options, too, like fine-tune its repair work. Anything particularly useful we should know about.
You are one step ahead of me. The Notch P option, that is a real gem. It tells Scrog to try and automatically fix any errors it encounters. Think of it as the fix-it button for your storage devices. Perfect for those moments when you just want things to run smoothly. But even with the best mechanic and the handiest tools, sometimes things go wrong. What happens if Schrock can't quite work its magic? Are those files gone forever?
That's a nail-biter. I'm almost afraid to ask, but I have to know.
Yeah.
Is there any hope of recovering those files, or are they just lost in the digital abyss?
That, my friend, is where things get really interesting, and it leads us to a powerful Linux command. Our source only hints at it. It's dd. Now, dd is a bit of a chameleon in the Linux world.
Right.
It can do a lot more than just copy files. It can actually create a bit-by-bit image of an entire storage device. And yes, that includes those deleted files that might not be entirely gone.
Hold on. Did you just say deleted files might not be gone forever in Linux? I feel like I just stumbled into some, top secret data recovery operation.
It's true.
We'll have to dive deeper into that right after this break. Okay, my mind is officially blown. We were just talking about how DD might hold the key to, recovering those deleted files, the ones that aren't really gone in Linux. It's like we've uncovered this secret society of data.
It's one of those aha moments that makes Linux so fascinating.
Right?
Remember how we were talking about how Linux treats everything as files?
Yeah.
Even devices?
Right.
Well, DD lets you interact with those devices at this incredibly granular level. It's like having this microscopic lens that lets you see and manipulate the ones and zeros that make up your data.
So even if the operating system thinks those files are, ancient history,
Yeah.
they might still be hanging out on that physical drive, just waiting for someone with the know-how to, sweep in with DD and bring them back. It's like digital archaeology.
You're getting it. It's a really powerful tool for data recovery, forensics investigations, and even, as you mentioned before, ethical hacking.
Right.
But we could spend a whole other deep dive exploring the ins and outs of DD. It's that versatile.
You're killing me with these cliffhangers. Okay, fine. We'll save DB for another day. But for our listeners who are busy, absorbing all this Linux storage wisdom, what are the key takeaways you want them to walk away with today?
I think the most important takeaway is that Linux has this very intentional and surprisingly elegant way of organizing storage. Even if it seems a bit cryptic at first,
Right.
once you understand that concept of device files, the logic behind those seemingly complex names, and the power of commands like mount and amount, it all clicks into place. It's like cracking a code.
It's definitely a different mindset than, just passively accepting those drive letters we're used to in other operating systems.
Absolutely. And this approach, it gives you a level of control and flexibility that you might not have realized you were missing. You can mount devices in very specific locations, manage partitions like a pro. You can even troubleshoot potential problems using those commands like df and fss. It's about becoming the master of your own storage destiny.
And let's not forget the sheer coolness factor of knowing that deleted files in Linux might not be gone forever.
Right.
That little tidbit alone is enough to make me want to, fire up a Linux virtual machine and start experimenting.
That's the spirit. There's always something new to discover in the world of Linux.
Well said. This deep dive has definitely opened my eyes to the power and flexibility of the Linux approach to storage. It might seem a bit intimidating at first, but once you understand the underlying logic, it's surprisingly intuitive and incredibly powerful. So until next time, keep exploring, keep learning, and never be afraid to dive deep into the fascinating world of Linux.